And it also says it's just weird that it's not like but if you read it, it says 3 samples are for coffee. Yeah. So it's kind of using the answer you just got.
Okay, what kind of problem is this?
ANOVA.
ANOVA. There's nothing up here. So it cannot be a matrix. ANOVA, we have 3 lists. And also, the 3 lists we have, they're all one variable, 3 different categories. Right? They have something in common. They're all the same thing. They're all authors. There's 3 different categories of author. Is everybody with me? How else do I know?
Mean.
So it says mean. Right? Once it says mean, all of a sudden you know it's got to be ANOVA. Okay. How about this one? Actually, hold on a second. I'm going to go backwards. Hold on. We'll do this one first. Okay, let's take a look at this one first. 15 seconds. Talk to your neighbors about it. All right, what kind of problem is this one? Matrix. It has labels here, it has labels there. Chi-stored matrix. All right, it also talks about relationship. Remember, relationship actually could be chapter 10 or it could be 11.2. It could be either one. They come into both. Okay, so now do this one. Chat with your neighbors, check in with them.
I think that I didn't work for down because I learned about money.
Okay, what kind of problem is this one? So someone said chi-squared. Why? Because we have proportions? So you use chi-squared? Is it a matrix?
No.
How do I know it's not a matrix?
Doesn't have top labels.
It doesn't have.
The top list.
So you're saying that this is three lists?
Well, there's not categories on the top and on the side. It's just on the side.
So we're saying that these are categories here, and these are not categories? So then we have 3 lists? Is that what we have going on? 3 lists?
No, it's just the actual is the observed, and then the expected proportion is the expected.
Okay, so we have actual and we have expected. Okay. So these are my observed, these are my kind of my expected, sort of. So then what are these guys? Categories. Those are the categories. Does that make sense? So this is a chi-squared list. Does that make sense for folks? And these are not the actual, these are expected proportions. These are not my actual expected values. Right? Because I can't compare 20 to 2/16. That's not fair at all. It's 2/16 of the total. Is everybody kind of understanding that? So this is the kind of the percent or the fraction I expect in each category. So typically you've had decimals, percents in each category. This is a fraction in each category. It's the same thing. Right? You're changing a fraction to a decimal in either one. Oh, you've had that before. You've had 1 6, 1 6, 1 6, 1 6 before 6. Yeah, it's just not, it's just a little more complicated fraction, that's all. All right, how about this one? I think we've got 2 more after this. So, talk to your neighbors about it, check in with them. Everything in chapter 10 and 11. Alright, so which one is this one? How do you know it's linear correlation? It says linear correlation.
Yeah.
Also, there are no categories across the top. Everybody see that?
Yeah.
So that means it cannot be a matrix. There's only 2 lists, so it can't be ANOVA. And it can't be chi-squared because even if this was observed and expected, we still have to have categories across the top, but there's no categories. Is that kind of following? So it can't be chi-squared list either. It's got to be linear correlation. Chapter 10. Good. Linear regression. Linear regression. Linear regression. Okay, how about that one?
Yeah.
Talk to your neighbors, check it with your neighbors, compare answers with them.
It is. It's my.
Your body's just going to change it.
Why do you use the chair?
Alright, so which one is this one, folks? ANOVA. It says mean. It has categories along the top or the side, but not both. Does that make sense? It can be one or the other, but not both. If it was both, then it would be then we'd be kind of thinking chi-squared matrix, right? Except for that mean part, which kind of qualifies. Okay. What about this one? Were you taking notes when I had this slide? Alright, which one is this one? What do people think?
Linear regression.
Okay, so there's one claim for linear regression. And there's a claim for chi-squared matrix. Chi-squared list. Anyone think ANOVA? No. Okay, so no nanny novas. All right. So let's see if we can read words that help us figure something out. So look through the words. All right, so matrix went away. So chi-squared list or linear regression. So these are the two you get mixed up the most often. So someone's thinking linear regression because I have Monday and 114. They match up. Is that what you're thinking? They're paired? They're paired up? The problem is that Tuesday is not a number. Tuesday and 152 may go together, but they have to both be numbers to have linear regression. You can't take the X bar of Tuesday, Wednesday, Thursday, Friday. Does anyone understand what I'm saying? So since my data is a category, kind of a category that goes with a number, it can't be that. And then also, what do I notice about this? Yeah, observed frequencies. Does that make sense? So frequencies are going to be what? Frequencies always have to be chi-squared. Has to be a chi-squared. And since this is not a matrix, it has to be a chi-squared list. Does that make sense to folks? A little bit better? So these are my observed values for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Yep, these are my categories, and I have observeds, which are 114, 152, 160, 164, 179, 196, 130. Okay. That one's kind of hard, huh? Okay. Oh, how about this one? This is an older chapter. Yep. What kind of problem is this? 15 seconds. Mean or proportion, Z or T, confidence interval, or hypothesis test. Which one is it? It's a confidence interval. How do you know that? It says confidence interval. Great. Is it a mean or proportion? How do you know it's a proportion? It says proportion. It has a P. And it doesn't say mean or standard deviation. Okay, so is it T table or Z table? Z table, easy peasy, PZ table. Also, point estimate. We said this is a proportion. So a point estimate should be a proportion. It should be a fraction. It should be a decimal or a fraction. Is everyone following that? Because my p-value is, sorry, not my p-value. What I'm looking for here is a proportion. So if I'm trying to estimate a proportion, then I should use a proportion to estimate. So my p-hat should be my best point estimate. That kind of leads me to this. So these are some of the common mistakes people made on exam 3. By and large, you all did really, really well. But these are some of the things that people had trouble with. One is figuring out whether it was a proportion or a mean. Right? And the difference between an x and an x bar. X bar is a mean. X, that's just your number of successes in a proportion. Remember, proportion will give you x or the percentage, but they're not the same thing. So a lot of times what people would do is if I asked for a point estimate, they would give me for a proportion, they'd give me x, the number of successes, which is completely not correct. Does everybody understand what we're saying? So your best point estimate is your best guess. So if I said, well, going from here to, okay, so if I said, out of our class, 20 students, 14 of them got an A. Or was there hearing what I said? So say 14 students got an A. And I asked you for what's the best point estimate of how all the classes did on this exam. What, I'm trying to find the percentage of how all classes did on this exam. Would it be would it be right to say, well, my best point estimate is 14? 14 what? 14%? 1400%? I said 14 students across the whole state. You know, your best guess at what everybody across the whole college is doing on this exam is not going to be 14. It should be a percentage, right? 14 out of 20. Does that sort of make sense? If I said to you, what's my best guess of what percent of students at Las Positas got an A on exam 3? 14? No, 14 out of 20. Good. So your best point estimate should be, if it's a proportion, should be a proportion, p hat. If it's a mean, then your best point estimate should be a mean, a number, your x bar. Okay. So a bunch of people, a lot of people missed that. That was probably the most commonly thing missed. Go ahead.
Does it matter if you put it like as a percent or a decimal?
No,
It's the proportion?
it does not.
Okay.
But you should not give me x.
Okay.
Yeah. And then some people switch z and t a little bit. That happened a little bit here and there. Some people did not finish step 3, so they didn't do steps 4 and 5. And here's the thing: even if you don't do step 3, take a guess at it. That way you can at least do steps 4 and 5 and get some points for those steps at least, if you understand how those parts go. And then with the confidence interval, don't just give me the margin of error. Give me the confidence interval also. Right? The margin of error tells me. So what's our best guess for how long it takes to get from here to Oakland Airport? I think we said 35 minutes, something like that. And then we take an error this way and that way. So say we take 20 minutes this way, 20 minutes that way. Is my confidence interval of how long it takes to get to Oakland Airport 20 minutes? No, it's 35 minutes minus 20 minutes, 15 minutes. 35 minutes plus 20 minutes, 55 minutes. It's 15 minutes to 55 minutes. That's my confidence interval. So is everyone kind of following that? So the confidence interval is when you take your best guess, your point estimate, subtract your error, take your best guess, add your error, and that number from here to here, your lower and upper limits. You have parentheses, lower limit, comma, upper limit, parentheses. That's your confidence interval. Okay. All right. So then, what kind of problem is this one? What are the twitching? This is what you have the most trouble with. And I really get to work on this. That will make a difference. I mean, theoretically, it's in the exam, so what do you think? Does it seem like a chapter 10 or 11 problem? Okay, so then it's going to be a chapter.
What are the categories of need?
Yeah, it's proportion. All right, so what is this? Is it a mean or proportion?
Mean.
It's a mean. How do you know?
It's an average.
Average, so it's a mean. Is it? Oh, it says standard deviation, right? Absolutely. Is it a Z table or T table? T table. Mean, Mr. T. Is it a confidence interval or hypothesis test? How do you use a hypothesis test? Yeah, you have a claim, you have evidence, right? And also, there's no words confidence interval or estimate anywhere in there. So again, knowing how to tell these problems apart is fairly critical because 25% of your exam is going to be chapters 7, 8, 9, 7 and 8 mostly. So, and I can't give you a whole ton of problems. So this one might be worth like 10% of your exam or 15% of your exam because, I mean, the thing, what am I going to do? I got 25% of your exam needs to be chapter 7 and 8. I can't give you 5 of these problems and expect you to get them all done in 2 hours, in that portion of 2 hours, in 1/4 of 2 hours, right? So I'm probably only going to be able to give you one hypothesis test and one confidence interval, and they're both going to be worth a fair amount of money, for a fair amount of points.
I wish.
So it's really, really important that you identify what kind of problem it is. Confidence interval or hypothesis test, mean or proportion, and you use the right table, T table or Z table, and nail these ones. Does that kind of make sense? You all did really well on the exam 3. So by and large, you should don't pay so little attention to it that you forget about it and then you screw it up on the exam, on the final. Does that make sense? It'll take you 5 minutes to kind of check your T's and refresh your memory on that so that you do well in this part. It's important that you do well in this part. Okay. All right, so let's go ahead and try a problem. Let's try let's try this one. So does anybody need scratch paper? I have scratch paper here, but anybody need scratch paper? So here, what kind of problem did we say this was? All right, work on it. Pretend like this is an exam. Work on it. Try to do it on your own without help, and then if you need help, just get little tiny hints. And this is a linear correlation problem. So this will be chapter 10, linear regression. You're going to H1 will be your claim. So you're going to either have enough evidence or not enough evidence to support the claim that there's a correlation between blank and blank, whatever your two variables are in your problem. A couple of hints here. So remember, linear correlation, chapter 10, that means it has rho involved, right? Rho, or that weird P thing. It has a little line thing that goes from -1 to 1 with 0 in it. Right? So that's kind of what you're using to compare. This is X and Y. Right? There's no alpha. Ooh, if there's no alpha, what's your alpha?
0.05.
Yep. Anytime there's no alpha, then the alpha is assumed to be 0.05. And again, you're going to use Lin-Reg t-tests. Just a few hints.